Hello student, today we will discuss the practical number 4 of your broadband communication system subject. The title of your experiment to set up the optical digital link for the optical fiber communication. The main objective of this experiment is to study how the optical link can be used for the transmission of digital signal. So digital signal may be either in terms of 10 or 01. So basically in this practical we are going to send any digital signal from transmitter to receiver through the particular optical fiber. Okay, so basically if you're going to look here, this is nothing but the optical fiber I am going to use for the transmission of your digital signal. So this is nothing but a digital kits. So with respect to these digital kits, this is nothing but a power supply. Then this is nothing but a pattern generator. Okay, by using this pattern generator we can able to generate two different pattern in this board. So this is a pattern 1, this is a pattern 2. For pattern 1, this pattern is used to generate the 1 0 0 0 0, while pattern 2 is used to generate 1 0 1 0 0 0. Okay, so these two signal we can able to send to the particular optical fiber from transmitter to the particular receiver. Okay, so initially we will generate the particular pattern with respect to the clock pulse. So this is nothing but the clock pulse. Initially I will keep this notch frequency at a minimum position. So this is the DSO. Everybody knows this is the DSO. This is dual channel DSO. So on channel 1 I am going to generate the clock pulse. So this is called the clock pulse. Then channel 2 I will verify the pattern. So this is nothing but a pattern. Initially I will use the pattern P1. Then second channel. Okay, so you can observe the pattern on the particular DSO. So this is nothing but the clock pulse. This is nothing but a pattern which we are going to generate. The pattern is nothing but the 1 0 0 0 0. Now whatever the patterns we are going to observe here, this pattern is totally inverted. That means whatever the output you can able to observe on the particular DSO, this is totally complementary with respect to this clock pulse. So my pattern is 1 0 0 0 0. So basically this is 1, then this is 0 0 0 0. Okay, now this is with respect to pattern 1. Now with respect to pattern 2, if I am going to apply pattern 2 is nothing but a 1 0 1 0 0. So this is a pattern 2. So my first step is that I want to generate the particular pattern which is P1 and the P2, and this pattern I will send from the transmitter to receiver through the particular optical fiber. So up to this case, this is the part I will call as a transmitter part. In this case we are generating the pattern 1 and pattern 2 in terms of digital signal. Then this is nothing but the receiver part. So between this transmitter and the receiver part I want to connect the optical fiber cable. So this is the optical fiber cable that I am going to connect between the transmitter and the particular receiver. So I will connect it. Okay, so I am going to connect this optical fiber between transmitter and the particular receiver. So in that case, if I am going to connect this transmitter to receiver, so there are two patterns are there. There are two registers are there, that is called register R1 and register R2, which is called as a load register. So I want to verify the receive signal with respect to the effect of this load register R1 and R2. The value of R1 is 1K, the value of R2 is nothing but the 4.7K. Okay, now I will remove these connections from here. I will check my output of transmitter. Okay, then this is the output. That output I will check with respect to receiver output here. R1, so this is the load register R1 I am going to connect. Then this is the receiver output. So this is the output I am going to generate at the output of your receiver. So such type of output I will generate. So this is basically called as a eye diagram. Okay, I am going to generate the eye diagram, and using this eye diagram we can able to observe the output at a receiver side. Then what is the significance of your eye diagram? Basically this eye diagram is summarized as the effect of ISI model, that is inter-symbolic interference, by showing the response of 0 and 1. Okay, normally at the input of this circuit or transmitter you are sending the signal in terms of 0 and 1. So this eye diagram consists of your basically 0 and combination of 0 and 1. So this eye diagram can be generated by overlapping the plots of receive signal for every symbol time. The resulted diagram is just look like a eye. That's why it is called